again, I'm sorry, I'm just checking if I set everything up correctly. Yeah, I do. I don't think about doing this beforehand. I do this exactly when I'm starting. The third time. Alrighty, what's up? Welcome back to the channel. As if you are new here, keep in mind that I'm not exactly a paragon of knowledge when it comes to the things I'm streaming about. I'm learning them as I go, and to kill some time, basically. What are we doing right now is that we are following a really great book on C called Build Your Own Lisp, in which we are building a simple variant of a programming language using the C programming language, a variant of the Lisp language, to be more precise. In the last episode, we finished a subsection on variables. We actually create implementation for the variables, and here we're gonna do some other things. Yet it's my tablet, and here we are gonna do something else, and that else is called functions. So let me just, where's the center here? Left, right, this must be a center. Functions. Okay, a completely new chapter. So let's talk about them. Basically, as explained as simply as possible, functions are just reusable pieces of code, small enough so they can be plugged into our code in order to be at different points in time. So basically, what they should do is they should make writing our code easier. They should reduce duplicate code. They should be easily pluggable. They should be basically a helpful little addition to the world of programming. Let me just turn on the book. So the book says, in reality, what each paradigm delivers is simply different abstractions. There has always been a trade-off. For each higher level of thinking about programming, some piece is thrown away. And this means no matter how well you decide what to keep and what to leave, occasionally someone will need that piece that has been lost. But through all of this, one way or another, functions have always persisted and have continually proven to be effective. Okay. So one way to think about functions is as descriptions of some computation you want to be performed later. When you define a function, it is like saying, when I use this name, I want that sort of thing to happen. This is a very practical idea of a function. It's very intuitive and metaphorical to language. This is the way you would command a human or an animal. Another thing I like about the functions is that it captures the delayed nature of functions. Functions are defined once, but can be called repeatedly after. I mean, that's simple enough. I don't want to write a lot of things because functions are obvious functions are obvious. If you are a programmer, if you worked with computers before, functions should be more or less obvious. But in basic terms, there are reusable pieces of code, right? They are usable pieces of code and defined once. They are defined once and they can be called repeatedly after. another way, another like mental paradigm of thinking about functions is the black box way of thinking. So it takes some input and produces some output, and it basically like those factory lines in which something just goes in, something is done, then it comes out. Yeah, and why is this important? Because we can think about functions without thinking about how they work internally or how they are computed. We basically have an input, which just produces an output, and that's it. That's the whole logic, the whole way of thinking about them. And thinking about functions as black boxes is also in a way the idea behind abstraction, basically, which allows layers of different complexity to work together by exporting some of that complexion into a separate piece of code. Okay, and another way to think about functions is as partial computations. Like the mathematical model, they can take some inputs. These values are required before the function can complete the computation. This is why it's called partial. But like the computational model, the body of the function consists of a computation specified in some language of commands. These inputs are called unbound variables, and to finish the computation, one simply supplies them. Like fitting a cog into a machine which was previously spinning aimlessly. This completes all that is needed for the computation to run, and the machine runs. Okay, so we have been given 3 definitions. Another one is partial computation. We see that when the computation runs, some physical process is going on in the machine. This means we recognize the fact that certain things take time to elapse, so that the function might change the program state or do anything we are not sure about. Okay, that's it. So we can look at functions from the point of, as far as I understand, from the mathematical point, right? From a computational point, and also from the computer point of view. Most probably the mathematical point is the one that's most advanced. Most probably it's a study of calculus or some other things. Yeah, all these ideas are explored in the study of functions called lambda calculus. This is a field that combines logic, maths, and computer science. The name comes from the Greek letter lambda, which is used in the representation of binding variables. Okay, simple enough. So what are we gonna do in this chapter? We're gonna add functionality to support functions in our language. So hopefully it won't take a lot of time. So how will this work? Most probably we'll need to extend our language. We will need to write some built-in functions that will create user-defined functions. And we also need to provide a way to support the function with a list of arguments. We can also probably just reuse the def keyboard that we wrote in the last chapter. When running the function, this is going to be evaluated with our built-in eval function. Okay. We won't use the def. So the book says we're going to use something different. And we'll be able to call them by writing something like this. Okay, x epsilon plus x epsilon. So I assume this is the name of the function, this character here. And to create a function which takes two inputs and adds them together, this would be it. So I assume these are the arguments, and this is the logic of the function. And then we can call the function by putting it as the first argument in a normal S expression. So we have this, we have x epsilon, we have plus x epsilon, 10, 20. So this is the way we call these functions. But yeah, we will use actually the def keyword, because it says here if we want to name this function, we can pass it to our existing built-in def, like any other value, store it in the environment. So we can do def. Oops, I need to use the curly brace. Add together, and this is the content of it, x epsilon plus x epsilon. Okay. Okay, so let's start. What do we need? We need so what do we need? We need to store a function. Store the function s and lvel, like we stored everything else in our program up until now. We need to find a way to extend our lvel structure so it can accept also the functionality for a function. So what does the function consist of? What does a function consist of? What does a function consist of? So looking at this guy here, what do we need? We need a list of arguments. We need the content, which will basically just be whatever there is inside the curly braces or inside our Go expressions, content of the function. What else? We need a way to store the values. Store the values. Okay. Okay, let's go back to the code. Oh, before we start, I should create a new chapter. I should create a new chapter. Chapter 12. How can I copy everything from chapter 11 into chapter 12? Will this work? No, I copy the whole chapter. I need the contents of it. Well, maybe like this. Maybe like this. Will this work? Oh, it works. Nice. So let me remove the variables. Let me change the name of this to functions.c. And let me just run it now. Compile it. Functions. And functions will be here as well. Functions. Okay, we have everything set up. Oh. Oh. Where am I? I think I started working on a functionality that would print out the name of the function. So it seems that I have forgot about this, but oops, I almost switched. By the way, I also want to stream maybe some of the things I watch on YouTube. For example, this is really interesting to me, but I don't know what kind, what's the licensing behind this, you know. I don't want someone to flag my. I mean, I don't want to do anything illegal. I don't want someone to. I I don't want to destroy someone's uh well-being because of me reusing their content. If my video for some reason, but it won't. If my video gets more views than theirs, I don't want to do this. Or I don't know. They come to my videos instead of the original ones for content. I don't want to do this. So I'm not sure what to do about this. I don't know if it's allowed to do this either way. Okay. We have the type helpful function here already existing. So we can store our built-in functions under the same type. But we need a way internally to differentiate between them. We can check, to do this, we can check if the L built-in function is null or not. If it's not null, we know that the L is some built-in function. Otherwise, we know it's a user function. Why? Why? We store our built-in functions and user-defined functions under the same type, L fun. This means we need a way to internally differentiate between them. To do this, we can check if the L built-in function pointer is null or not. If it's not null, we know that the L is some built-in function. Otherwise, we know it's a user function. Why is this like this? Let me just see what ChatGPT has to say about this. Why? Why would? Oh, wait, I don't want to ask anything. So we will store our built-in functions and user-defined functions under the same type. Okay, this means we will need a way to differentiate between them. Okay, I understand this. The L built-in function pointer is null. If it's not null, we know that L is some L built-in function. Otherwise, we know it's a user function. Ah, okay. I think I get it. I think I get it. So we are looking at this particular property here. So we will most probably, for the user-defined methods that we stored in our environment, which we did in the last, I don't know, 2 or 3 videos, for these kinds of properties, we won't do anything. Okay, we won't do anything for this. But for the user-defined, we'll most probably extend this, and we won't reference this for user-defined methods because we already referenced these in. Maybe I can find it here somewhere. Maybe I can find the constructor here. Function. Yeah. So here I referenced. Is there any other way where I reference this? Fun. Okay, so I referenced here in the constructor method, I referenced the property fun of the Lisp value. So most probably in the extended version in which we'll use the user-defined methods, we won't set this up. So we will know the difference between the default methods and the user-defined ones. Okay, so let's extend this guy. Let's extend this guy. Let's just extend this guy. Function. Function. I don't like this theme. It's so similar. The commented piece is so similar to the background. So I have the function. Then what I need is the environment. Why? No idea. I'm just following the book. Formals, which would be most probably the parameters. And what else do I need? The body. That's it. And change the name of the property from fun to built-in. So let's also change it. Fun. This is gonna be built-in. Save. Fun. Where else do I have it? No, here. Where else do I have it? No, I have it here as well. Okay. I don't care about this instance because it's not function. Fun. I change it here. So I need to change it to some other places as well. So here it's gonna be built-in. And here as well it's gonna be built-in. So both of these are Lisp values, LVAL types basically, right? Why? What is happening here? Where is the beginning of this method? Ah, it's here. Okay, I need to. Let me just check something. Does Vim have auto formatting? I highly doubt. I highly doubt this. But let's see. Amazing. Thanks, Vim. Vim has built-in commands like equals for formatting code. For example, you can use gg equal g to auto-indent the entire file, or I can use Python specific comments to do something else. I'm fine with this. I'm fine with this. Looks nice. Looks nice. I don't think it changed my custom formatting. Looks really nice. Will it? Why is this happening? What theme am I using here? IO Mirage. I need to fix this. I need to fix this. Function. Yeah, fuck, I need to do this by hand now. Functions. Functions. Hello has no member named 439. So here I also need to change the instance to be built in. Save. Change here. Try to compile it. Everything works. Amazing. So first thing is done. First thing is done. Let's go back here. What we need to do now is we need to create a constructor for user defined functions. How to do this in the context of our script? How would we do this? So the way I'm learning this, the way I'm streaming this is I'm following the book, but once I come across a snippet of code that I see it's a snippet of code, I've usually tried to hide it, to obfuscate it somehow, and try to think of a solution on my own. Then if I don't get anything, I would slowly reveal, I would slowly scroll, see the proposed solution, and try to solve it on my own. So in this case, it says here, we should make sure to change, okay, we need to create a constructor for the user-defined LL functions. Here we built a new environment for the function and assigned the formals and the body values to those passed in. So it's called I don't like red. I don't like red for descriptions. What's the difference between this color and this color? Which one looks better? Yeah, most probably the one that fits better on a black background. So this is how we created formals, which I assume are the arguments, and the body, which assumes the body, are the parameters. Okay, let's do this. Let's do this. Where are you? Where have I created you? Here. I created you here. So I'm gonna create another one right below you. It's gonna be called LL lambda, and it's taking what? It's taking. Okay, I'm gonna change this. I'm definitely gonna change this theme, because look how badly the braces and the parentheses are highlighted. These colors are really ugly. but don't fret. Let's do this. So what do I have here? I have the formals, I have the body. So these are the parameters for this. These are the parameters. What I'm gonna do, I think it goes like this. I'm gonna assign some memory for this. Just a second, just a second, just a second. I can't, it hurts my eyes. It hurts my eyes. Just a second. Where are you? It's this. Where are the colors here? Color palette. Background, scrolling, compatibility, title bar. No, I don't want this. What's the color for selecting this? Can I change it? I can change it, but I don't know what the colors for It doesn't even say what the colors are for. Okay, I won't touch this. I won't do anything here. I won't do anything here. Why is this here? Why are you here, bruh? What happened to you? You are the closing one, and you are the open one. Okay, we assigned a new empty Lisp value with some memory according to how much it needs. I'm gonna set type. I'm gonna set the type to be LL function. Fun. What else do we need here? So I have these guys. So most probably I'm gonna do. Sorry, let me just. Less. Very functions. Yeah, I want to compare what I already have to what I'm writing. So what I do, I have v formals equals formals, v body equals body. Do I need to address some memory for this? Most probably not, right? No, seems I'm right, but also I need to set the built-in to null, so we have a clear distinction between the user-defined and the built-in methods. And we need a new environment where we're gonna keep and store our variables. Nice. Okay, the book is saying following. We need to update our functions for deletion, copying, and printing to deal with the changes. Okay. Okay, but before this, how to open Win in read only mode. Most probably there is a way to run it. I want to have syntax highlighting. Like this. R functions. Nice. Now I can compare between my coding screen and the one that is read-only without needing to scroll unnecessarily and losing my progress. To open a file in Vim, you can use the following command, or you can use view file name. View functions.c. Nice. This one also works. Okay, I'm gonna use view for now on. Cool. Cool. We need to update the functions for deletion, copying, and printing. Delete. No. What's the name for the deletion one? Case L1. This is it's not delete, it's only del, the first three letters of it. Okay, let's fix this. Let me just remind myself what I wrote here. So I'm switching based on the type. If there's a number, I'm doing nothing. If there's an error, if there's a symbol, I'm freeing this memory. Why am I freeing this memory? Because there are no built-in strings. See, these are array pointers of characters which are taking memory, right? That's why we need to free them. S expressions, Q expressions do the same thing. They are just calling the method recursively. And why are they doing this? Because they are ripe with different data and a lot of nested Lisp values. So what they basically do here is they iterate through the children of the Q expressions or S expressions, call recursively again the L delete, which is the same method, clean everything, then come back, and once we cleaned everything, we can free the Lisp value itself. But this case is empty for some reason, so now it's time to extend it. Will this work like this? I think it will work like this. If there's no built-in method, if it's null, if we created a custom user-defined method, let's remove the environment. Let's delete this data, and let's delete the body. Simple. Where's the other case? L1. Where's the next one? Here, inside the copy. So how should this work now? This only works if we have a built-in method. If we have a user-defined method, we need to check against whether the built-in exists. So this should be like this. Let me just do this. Insert. Why am I? Why do I have a feeling it isn't where it's supposed to be? Look. Yeah, definitely it's not where it's supposed to be. Okay, I don't care about it. So what do we have here? If, let's do this again. If we have the built-in method, please do this. Please do this if we have the built-in method. And I'm gonna remove the break here because it's not needed. Otherwise, the built-in will be null. We'll copy the environment. What else? We'll copy the formals. We'll copy the body. Keep in mind, I'm just following the book because I wouldn't have any idea that we have all of these built-in methods. I forgot about them. Okay, that's it when it comes to copying. And now printing, it's here. It's here. So what do we have here? If it is a built-in method, what am I gonna do with you? What am I gonna do with you? It's a built-in. Otherwise, I have troubles with Vim. I'm sorry. I have troubles with Vim. Else, same thing. F, what am I gonna do? So it's gonna be like this. I will print v formals. I will print v body. Then we'll have some put cars here. Put car this. And this. I think this is okay. I definitely need to change this. This theme, not ugly as hell. It's ugly as hell. So let's continue. Let me just compare this with this to make sure. Yeah, I wrote it correctly. Okay, let's talk about lambda functions now. Lambda functions. We can now add, I'm reading the book now again. We can now add a built-in to our lambda function. We want to take an input, some list of symbols, and a list that represents the code. After that, it should return a function, lval. We defined a few of built-ins now, and this one will follow the same format. Like in def, we do some error checking to ensure the argument types and count are correct. Then we just pop the first two arguments from the list and pass them to our previously defined function, lval lambda. Okay. So where are the built-in methods? Where do they live? They live here. Built-in join, built-in eval. Where is the built-in? Built-in eval. It's here. Oops. Wait, come back. So this lval built-in lambda that will take what? It will take the environment. It will take the Lisp value. And now we have the content of it. Then we have the content of, I can see shit. Why is it so badly? This one's also ugly. This one as well. Go with this one as well. I mean, I'm gonna come back. I like the colors. The only thing that I don't like is the way colors work when highlighting stuff. So let's do this now. Okay, so this is the way how we built these methods. So this is our lambda function. We want to take input, some list of symbols, and a list that represents the code. And it should return an lval function. Okay. Okay, so let's first do some assertions. How does this work? Sorry, wait. So what are we asserting? We are asserting the count. In the book it's called the num. I'm using count. I'm providing the arguments, which are going to be the lambda expression, which is written like this. What else? I have the number. Ah, shit. I think I messed something up in the way I define this method. Even though in the last episode I was like, oh, this is gonna work, don't worry, it's gonna be amazing. It isn't. It isn't amazing at all. How is this defined? Ah, okay, so this is the function. So this is not... Okay, I think I get it now. So a count will be our arguments. A, the number will be 2, and this is this. I just need... It seems that I need to use the double quotes here. The double quotes, all right. What else? Let's test against the type. So the argument is A. The element that I want is A is 0, right? No, it's not like this. How am I using assert type? Ah, like this. Okay, so I need cell the first element. The type should be what? Quick expression. And the name of the method is the lambda method. Same thing here. The only difference is I'm checking against the first element, and this should be it. So for those of you who don't understand it, even though I think I'm a bit drunk on it as well, what is happening here is that we provided something like this, most probably. Let me just copy this so I can use this on another place. Can I copy it here? I think I should. Come on. Paste it. Why can't I paste it? Ah. Okay. Let me just remove the unnecessary things. Okay. So what is happening here? Let's say we provided something like this. So we want to check a couple of things. We want to check that we have two elements, which will be this guy and this guy. So the list of arguments and the content of it. That's why we are testing against, that's why we are asserting that we have two elements. That's why we are asserting that the first element is a Q expression, this one, and that's why we are asserting that the second element is a Q expression as well. So these are our assertions. Now, at least that's how I understand it. So now, no. So the first Q expression should only be a list of symbols. Less than what? A cell, the first cell, count I plus plus. So the first one should only be symbols. L assert type. How is this working? Again, I'm providing what I can see anything. I hate the syntax highlighting. What should I provide here? Not VA. I think I'm providing this. So I'm providing, I think this will work. If not, if some memory management issue comes up, I think I'll know where to find the source of it. So this is gonna be a cell 0 cell I type. It should be a symbol. And it should be like this. I hope this is correct. I hope this is correct. It should be. It should be. So what now? Now I should get the list of arguments and the body the list of arguments and the body, and then I'm gonna delete this guy, and then I can return the lambda method, formals body. And let's register this with the other buildings. It's here. It's here. So if I close this, if I run this, a lot of issues appear. 138. Implicit declarations to function length new. Because length new is where? Here. It's here. Here's length new. Okay, let me copy this. Let's go all the way to the top and maybe define it here. No, not this. I hate this. I hate this. Where is it? No, it's here. Why can't I copy it? Save. Have I saved this? Unknown type name length. What? Ah, okay. Need to delete it. I need to delete it and maybe, sorry. Let's just paste it here somewhere. Maybe here. Paste. And save. Okay, we reduce the amount of errors. That's important. Inputs declaration function. Let me delete on page 160. Let me delete. It's here. This is how it looks like. Copy it. Let's go all the way to the top where we declare this one. Insert and paste this. And save this and do this again. Great. Let me just also copy. I have a couple of forward declarations here as well, but I don't know where exactly. Where are you? Where are you? Where are you? With the one here. How many do I have? 2, 8, 7, 1, 2, 3, 4, 5. So I'm gonna do 5, delete, right? 5, delete, yes. And I'm gonna paste them all the way at the top where we define these as well, just so they all stick together. Paste. Good enough, right? Yeah, good enough. Let's see what happens again. Len copy. Where are you? Oh, it's here. Okay, what now? Have I saved this? Len copy. Is this? Ah, this is how I'll copy. Fuck. Oh man. Len copy. Where's len copy? Do you have this method here? No. Ah, okay, so we haven't defined this yet. 258, 258. So this is going to be body. This is the issue. So we need to also implement this method as well. That's going to copy the. Yeah, I think that's it. Did you mean this? Copy and function alpha lambda 150. Where? Oh, I need to return this. Silly me. Return v. Silly me. What? Undefined reference. Yeah, that's the issue. That's the issue. I need to implement a Lisp environment copy function, and then it's gonna work. Okay, let me just get some water. Let me just relax a bit, and I'll see you back. Okay, I'm back now. Uh, I think I will call it quits for now here. The other thing that I wanted to mention is I want to learn just enough C and Python so I can do some real programming, so to say. So in order to do this, I'll need to do some other things. For example, I need to learn it, right? Okay, let me just do something else. Okay, so I want to learn Python. I want to do something with Python. I already know the basics of Python, but I would like to do a book on Python. So how should I do this? What are some of the best books on Python? There are many excellent books of Python catering to different levels of expertise and areas of interest. Here are some of the best Python books. For beginners, I don't think I'm a beginner. Automate the boring stuff. Python. This is actually a good book. I read it once. Maybe I should try to go through it again. Python Cookbook, Advanced Python Programming, Serious Python, Black Belt Advice, Specialized Python Book, Deep Learning with Python, Jungle for Beginners, Think Python, Programming Python. Okay, what about some Python books that deal with AI? Hands-on machine learning, Python machine learning, AI with Python, deep learning. Okay. So let me try to get my hands on some of these books, and maybe we'll do some Python programming that includes machine learning and